So we'll try to do it today. Okay, so on your green parent function sheet, we already looked at 2 to the power of x, which was growth. Today we're going to look at exponential decay, which is, we're going to use the base 1/2 to the power of x. So exponential decay is anytime you have a b value that's less than 1. So between 0 and 1, it's not going to be negative, but it's going to be a fraction or a decimal, less than 100%. So the parameter changes, remember we looked at for growth before spring break, just to refresh your memory. Right here is my left-right parameter change, insiders lie. And then on the end is my up and down. In the front, I could have a dilation, and I could have a reflection. Be careful if you're typing these in your calculator. If you have an h value, make sure that you use raise, and then you type your x plus or minus the number, and then close your parentheses. And then the k value gets added or subtracted after that. You always have to put this in parentheses or it won't graph it right. So let's go ahead and we'll make a table for 1/2 to the power of x. So if I took 1/2 and raised it to the power of 0, what would it be? You guys remember? It's always the same number. It's always 1. Good. And if I took 1/2 and I raised it to the power of 1, anything raised to the power of 1 is always just itself. So 1/2 to the power of 1 is just 1/2. 1/2 to the power of 2. So if I took 1/2 and I multiplied it by 1/2, what would I get? Yeah, I would get 0.25. So 1 times 1, 2 times 2, or 1/4. So I'm going to write it as a fraction because sometimes it's easier to see the pattern. But if you typed it in your calculator, you'll have those decimals, 0.25. So if I take that 1/2 times 1/2 times 1/2, that's the third power. I'm going to get 1 times 1 times 1 on the top. 2 times 2 times 2 is 8. So I'll have my 1/8. Now if I go in the negative direction, what's going to happen is I'm going to take 1/2. So let's see, I'm kind of making some notes down here. Let me make a little room. I would take my 1/2 and I'm raising it to the -1. So remember the rule we talked about? I don't want negative exponents. So I'm allowed to take that negative exponent off and make it a +1, but I have to change the numerator and the denominator. You have to flip it. So 1/2 to the power of -1 is really 2. And you can, if you need to, you can always use your calculator to raise it. 1/2 to the -2. So if I took my 1/2 and I raise it to the -2, and I take that negative sign off, it's really just 2/1 squared, which is 4. So you can kind of start to see the pattern, and this one's 8. So they match. It's the inverse of growth. It's the inverse of 2 to the power of x. And you could get the counting pattern just by entering the equation in your calculator, but it'll give you decimals. Okay? And so when you plot points on a graph, you want to make sure you plot exact points. Like when I was grading your quizzes, I looked for exact points. So don't just wing the curve, although it's good you know the shape. I still give you points if you knew the shape, but you should plot some exact points. So for the parent function, I don't have any left, right, or up, down changes. So I'm graphing it from the origin. And so remember before the break we talked about the little bullseye. So I make the little bullseye from where I'm graphing it after I make my left, right, or up, down parameter changes. From there, I can tell what the asymptote is, and it's already kind of drawn on the Smart Notebook. It goes through the little target, and if I don't move it left or right or up and down, then it's a horizontal asymptote at y equals 0. So you always want to make sure that you use the y equals 0 to tell the reader that it's a horizontal line. And so I always tell people, remember HOI, horizontal, 0 slope, y equals equation. There are no vertical asymptotes. its y-intercept. So we're getting ready to start plotting it. So from my little target, I have 0, 1. That's my y-intercept. Okay, it's not going to have an x-intercept because it has a a horizontal asymptote. It's never going to cross that dashed yellow line. So let's plot the other points. So at 1, a half. At 2, a fourth, and then an eighth. So those points are kind of hard to see. When you draw it in, make sure you don't cross your asymptote. And then going back to -1 is 2, -2 is 4, and -3 is 8. So these points are easier to plot when it's decay on the left. The domain is the same as growth. It's all real numbers. Did anybody take the SAT on Saturday? Yeah, somebody told me that in 7th grade that some of the answer choices were all real numbers. So did they write it out or did they use the double standard R? Okay, because you'll see that instead of sometimes negative infinity to positive infinity. It's the same thing, all real numbers. The range is going to be your K value where your asymptote is. So it's all the numbers greater than 0. Okay, so that is what decay looks like. And then your notes over graphing, we're going to do graph a couple with parameter changes, left, right, up, down, and then one with a dilation. And then we're going to look at the last bit of exponent rules, writing fractional exponents. So the first one, what's it going to do? What's that x plus 2 do? Yes, good. Left 2. What's that big -3 going to do? Down 3. So the very first thing I'm going to do, my parent would start at the origin, but I'm going to go left 2, down 1, 2, 3. That's where my little target is. Okay, from there, I can draw my asymptote. My asymptote matches my K value. So it's the equation y equals -3. So I'm never going to cross that when I draw it. And I'm just going to use my counting pattern. Okay, these aren't actual points on my graph, but I'm going to use my counting pattern to graph it. It's almost better to put the 0 down here. 0, 1, 1, 1/2. And then -1 is 2, and -2 is 4, and -3 is 8. So those are easier numbers to graph. So those aren't actual points, but that's my counting pattern that I'm going to use when I graph this guy. So power of 0, up 1, power of 1, 1/2, power of 2, 1/4, 1/8. And you know, if you do like 1 in each direction, usually it'll say like graph 4 good points. So 1/2 to the -1 is 2, 1/2 to the -2 is 4, and 1/2 to the -3 is 8. So I'm just using that counting pattern from the parent after I did my left, right, up, down. So that's how you can graph with parameter changes. You could check it with your calculator though, just be really careful and close your parenthesis after your exponent ends. Okay, so our domain, we said all real numbers. Your range, what's the range going to be? Where does it start? Yeah, it matches your asymptote, it matches your K value. You might see a negative sign in the front. That would be a reflection, but there haven't been any on the notes. So if you were graphing a reflection, instead of going 1 up, you're just going to go 1 down, and it would look like it was on the bottom. But I haven't seen one like that in our notes. There might be one on your bird assignment. So the next one, it's kind of the same thing. It's got left, right, up, down. It also has a dilation in the front. So what does the -4 do? It goes to the right 4. Good, because insiders lie. How about the +1? Up 1. Good. And how about the 4 in the front? Times 4. Sometimes they call it a dilation. It's taking the y values and multiplying them by 4. So she's giving you kind of a little place to do that. So let's see, 8, 4, 2, 1, 1/2. So she's just giving you a little place to make that dilation and multiply these values by 4. Because that's all we're doing is we're changing the y values. So I would always go ahead and do the left, right, up, down first. So y'all said it's going to go right 4, 1, 2, 3, 4, and up 1. That's my little target. That's where I'm graphing from. So I can see my asymptote, and it matches. It's at 1. So my equation would be y equals 1, and now I have to graph it. But when I graph it, I'm going to take my y values. So instead of 0, 1, I'm going to multiply it by 4. So it's going to be 0, 1, 2, 3, 4. Instead of 1, 1/2, it's going to be 1/2 times 4. So 1 and then 1/2 of 4 is 2. And then I can't really see the other numbers because this one would be 8, 16, and 32. So sometimes it's better to go the other direction. So squared would be 1/4 times 4, which is 1. So this point would be here. And then you can't really see it. It would look like something like that. So your domain is always the same, all real numbers, and then your range. What's your range going to be? Where does it start? 1. And even though it's real far above that, it's always your asymptote. Okay? It's going to get closer and closer to your asymptote, but it's never going to cross it. Okay, questions about the graphing. So it's just like 2, but it's decreasing from left to right because this is decay. And your calculator will graph them for you, but we want you to see that you can graph them without your calculator. What do you think? Questions? You're almost through the first day back from spring break, right? You look a little tired. Is it too much math the first day back? A little bit? Okay, let's do the exponent rules. Maybe they'll be a little easier for you. I really hate the boxes. I hate the boxes, but we can kind of talk about them a little bit, but I don't want to dwell on the boxes. What's the opposite of a square root? Square. Okay, so raising something to the second power. What's the opposite of square or quadratic? Square root. Okay, so what they want you to think is, what power would I need here to make this x a power of 1? I'd need to square it because I'd need to have 2 x's in there in order to be able to take the x out, so the w would have to be a 2. And then the other one, if I wanted to take x squared and I wanted to create x to the power of 1, I'd have to raise it, so I need 2 times 1/2 would give me x to the 1. Okay, and somehow they think that kind of helps you wrap your mind around the rule that the square root of x is the same thing as x to the 1/2 power. I'm not sure I love the box, but this is a new TEK for Algebra 1. We've been teaching this in Algebra 1 for 2 years, so you may have seen it before. And what I tell my kids is when you're writing a fractional exponent, the fraction on top is the power. Okay? And power is another word for exponent. Right? Raising something to a power, an exponent. And so I use the word power because I think it helps people remember. Right? Anybody got a power? Everybody's got a different power, right? Your power's usually up here somewhere, right? It's up coming from above you, up in the clouds, whatever you think about. That's where your power is. And so that's where your exponent is. Okay? I'm not going to get too deep with that, but it'll help you remember. On the bottom is your root or index. but we talk about it like a root, like a square root. And where have you experienced roots in your life outside of math? On the ground, which makes sense because the power is on the top and the root is on the bottom. So it's going to help you keep them straight. So the way we rewrite a to the 1/2, a, its power is 1, its root is 2. Okay, so like on a cubic, or a cube root, we would put the 3 as the index. It tells you how many you have to have in a group to take something out. So I think that helps people remember. Okay, not trying to be weird with that. I just think it's a good way to remember. Power, root, because it makes sense. The root's on the bottom, the power's on the top. So if I rewrite this, this is 36 to the power of 1. That's its power. It's on the top. And it's the square root. Okay, most people don't put the 2 on there, but I don't care if you do. It'll help you keep track of what group you're taking out. So what's the square root of 36? That's all that means. And your calculator will do that too. So like if this ever stresses you out, like let's look, and I don't think I did that with my other classes today. Let's see, where's my TI-84? Did I close it? I may have closed it. But take your calculator if you have one, and take 36 and raise it to the 1/2, but make sure you put it in parentheses. So your calculator will do a fractional exponent and then raise, and then make sure that you put it in the parentheses, and yours might not write it nice and neat like mine did because you may not have the update. It might just have an arrow. Make sure you close your parentheses. Where are the parentheses? Is it above the 9? No. Can't see it very well because of the glare. Yeah, it says it's above the 9. There we go. Okay, so 36 to the 1/2 is 6. So I just want you to see that your calculator will do it if it's numbers. But lots of times they don't give you numbers because they want you to know the rule. So like this, m to the 9 to the 1/2 means m to the 9 to the 1. That's its power, and that's its root. Power, root. Okay? So if I take m to the 9th and raise it to the 1, is it going to change it? No, it's just 1 times 9. So really what we're talking about is the square root of m to the 9. Now that won't always be a 1. It might be a different number. So now if I wanted to reduce that, if I had 9 m's and I want to take out as many groups of 2's as I can, so here's my 9 m's, I could take out 1, 2, 3, 4 with 1 left over. So I have m to the 4th, and it's the square root of leftover m. And you can put the index if you want to. You can write the root on there if you want to. But most people, you won't see it always on a square root. So this rule, I bet you guys can figure out what undoes a cubed root. What's the opposite of taking the cubed root? Cubing it. And so if I wanted to take an x out and just make it x to the 1, what power would I have to raise it to? The 3rd. If I raised it to the 3rd power, the cubed root of x times itself 3 times would give me the cubed root of x to the 3rd, which would make x to the 1. So a cubic, the opposite of a cubic, is a cubed root. And so if I wanted this to be a 1, what number would I multiply that 3 by? 1/3. Good. So I would multiply it by 1/3. And so it's really just the same rule. If you think of it, it's x to the 1, and it's the 3rd root. So x to the power of 1, the 3rd root, is the same thing as x to the 1/3. Power root. So it doesn't matter what fraction it is. You just have to kind of remember that rule. So a to the 1/3 is the same thing as a to the 1, and it's the cubed root. Has anyone ever seen these before? If you saw it in Algebra 1, you may or may not remember it. We only do it for a few days. So when I'm rewriting, power root 27 to the power of 1 cubed root. Just means cubed root of 27. What's cubed root of 27? 3. And you could get your calculator to give that to you if you weren't sure. 27, raise it to the 1/3 in parentheses. Okay, so this guy, I've got x to the 10, y to the 5th. What's its power? Looking at that fractional exponent, what power is it? 1, which isn't going to change these numbers, but it's not always 1. And it's the cubed root. So if I had x to the 10, how many groups of 3 can you take out of 10? 3. So you'd have x to the 3rd, and you'd also have 1 left. And then how many groups of 3 can you take out of y to the 5th? 1, and you'd have 2 left. Okay, so I kind of wrote them far apart. This is the index. It's not the power. The power of the y is 1. That's the root. So the rule is a to the fractional m over n, a raised to that fraction, is the same thing as a to the power, it's on top, the m, and it's the nth root. And so she has over here numerator equals regular exponent. I think power and exponent mean the same thing to you guys. Power's on top. It's an easy way to remember it. Root's on the bottom. Okay, because that's really all you need to know. Power's on top, root's on the bottom. So sometimes it's not 1. So 4, what's its power? 3. What's its root? 5. Good. So what's 4 to the 3rd power? Anybody calculator? 64? Okay, so now I would just have to know that that's what that means, because I really have to raise it, and now I've got to reduce it. So 64, it's an even number. I would start dividing it in half. It's still an even number, so I'm just factoring it. I'm just dividing it in half, and I'm factoring down to its prime factorization. So there's my 64. And then I would take out, because it's a 5th root, 1, 2, 3, 4. I have 5 2's and 1 leftover 2. So you're not going to do anything real crazy. That index, that 5, just tells you you have to have 5 of something in order to take it out from underneath. Okay, so the power is not always going to be 1. Most of the time, probably. So this guy, I've got m, what's its power? 8. And what's its root? 5. So how many can I take out if I have 8? Well, how many do I have to take 1 out? 5. So I have, let's see, 1, 2, 3, 4, 5. So when I take it out, it's just m to the 1. 5 m's means I take out m. And then the 5th root, and I have 3 left over. Okay, so that's all you have to know about fractional exponents. The fractional exponent means power, root. What do you think? That's all you really have to know. If you can remember that, then you shouldn't have a problem with those. But I think that's probably the trickiest exponent rule we look at. So if you felt like, ooh, that was a little tricky, you won't. That's really it. That's the last one. So you might want to put that one in your composition book, so you have those exponent rules if you needed to look at them. Do you guys have questions over this? What do you think?